This is Vartika Singh from the team The Thunderbirds, and our project is Smart Refueling System. Technologies today are really budding, and one of such technologies is robotic arm. Robotic arm is used in many research projects as well as assembly lines. Other technologies like 3D image processing are also among the budding technologies which are used by students as well as institutions for many different projects. Such technologies, but yet being so amazing, have not been implemented completely in industry, for which we have come up with a project where we are trying to integrate these amazing technologies for the benefit of common people in daily life. One of the problems addressed by us is the refueling of the stations, refueling of the vehicles at the stations. The problem faced by general public here are the time they devote and the money they have to spend in the entire process, for which we have we are integrating these solutions where we use a robotic arm for programming and as well as performing the refueling, and 3D image processing has been used to locate the vehicle.
The list of components include TI components, Beaglebone Black development board, non-TI components, metal gear dual shaft servo motors, RK12324 servo accessory pack for dual shaft servo, 5 volt 30 ampere SMPS, 150 watt DC metal power supply, 12 volt water pump, DC geared motor with encoder, 2 Logitech HD cameras. Whenever a car enters a refueling station, the first step that needs to be performed is making an online payment using an Android application. As soon as the details of the payment are received by the development board, it accordingly sends values to the barricades to open up in order for the car to enter the refueling space. Once the car is parked successfully, the 2 cameras are used to perform 3D imaging in order to calculate the coordinates of the opening of the fuel tank of the car. According to the calculated values of the coordinates, the development board gives values to the servos of the robotic arm for the arm to extend and reach the cap. A proximity sensor signals a successful arrival. The cap is then opened and refueling is performed. Once the refueling is performed successfully, the cap is closed and the arm is withdrawn, which then moves back to its original position. The barricades then open up and the car is ready to leave.
The following video shows the prototype of the arm which we are going to use in the product in order to refuel the vehicle. This arm is based on servo mechanism and has 6 degrees of freedoms. Basically, it can move in any direction and is pretty robust to do the job.
The use of such latest technologies brings a project to another level of automation and digital transformation of the industry. The project involves implementation of technologies from various technological disciplines such as robotics, image processing, robot operating system, CAD modeling and simulation, app development, and robotic arm technology. Automation of refueling stations has not been introduced nationally, and on international platform, though the automation has been introduced, the implementation of robotic arm has not been accomplished successfully yet. The use of robotic arm to provide extra degree of freedom and implementation of indigenous algorithms in order to devise the product makes our product a breakthrough one. We have planned to proceed by installing our product on existing refueling stations with slight structural upgradation of the station. In order to locate the position of the fuel tank, we use the technology of 3D imaging, where 2 cameras at finite distance from each other capture the image of the car and calculate the coordinates of the fuel tank opening using image processing methodologies. The calculations are demonstrated in the shown diagram.